Welcome Algebra 1 students to the Algebra 1 Unit 1 review packet. It covers these lessons. We're going to see problems from each of those lessons as we go through here. This is meant to be a guide, a help for you, just for the questions that you need help on. Don't watch this whole thing straight through and just copy things down. That's not the point. We're trying to get ready for a test that we're going to take. So I want you to treat this like a practice test. Do all these problems on your own the best you can first, and then use this video as you need for the particular problems you need help on. So go ahead, feel very encouraged to skip and rewind and pause and fast forward as you need. Use this video however you feel best. If you want to watch the whole thing and you want to hear my explanation of all the problems, you may find that very helpful. Be my guest. If you'd like to do that, use this video in whatever way you see fit, but I want you to try all the problems yourself first. So let's get right into it and check and see what we got here for numbers 1 through 4. The directions for these first ones are just solve each equation and show all your work. So this, I know on yours it might have a lowercase m instead of uppercase m, so I'm just going to use what I see here. But if it's lowercase on your packet, use the lowercase m instead of the uppercase m. But this would be m, and then minus a negative would be plus 4 equals 7. We're trying to get the m by itself, trying to solve for the variable in each one. So here I'll subtract 4, and doing that gets the 4's to cancel. I'm left with m equals 3. That's it. That's my final answer. I will box that in. So I showed my work and I solved the equation. I could go back to the beginning and plug that back in to check. I'm not forcing you to do that here, but always a good idea. So this would be 3. This would be plus 4, would in fact equal 7. Let's move on to the next one. We've got, in this case, x minus 13 equals 8. Looks like we could add 13 to both sides. So those steps I'm showing in red, and then what I get after I apply the step, I'm showing that in blue. So this would cancel out. I've got x equals 8 plus 13, that's 21. If I plug 21 back in for x, I get a solution that checks. 21 minus 13 does in fact equal 8. Number 3, we're going to divide this one by 5. Looks like we have negative 75 divided by 5. The 5's here will cancel, and I'm left with n equals negative divided by a positive would be negative. 75 divided by 5 would be 15. So this one, n equals negative 15. Let's keep going. This one I'm going to write the equation over again just so that 4 doesn't get in the way of what I want to do here next. And so I noticed that I'm dividing by a 4 and it's negative. I want to get rid of the negative and I want to get rid of the 4. So to undo division, we're going to do multiplication. So I want to multiply everything by 4, but I also want that to be negative to get rid of this negative sign. So multiply by negative 4 on this side. Got to do the same thing in algebra on the other side to make sure that it stays balanced. So we have n equals, this would be negative times negative, positive. 12 times 4 is 48. Plug that back in to the original equation. You'd have negative 48 over 4, which would in fact equal negative 12. The next one, same directions, but now the steps are getting aren't getting more complicated. We're just adding more steps into these equations. So multi-step equations now. Subtract 3 from both sides first. I'm trying to get x by itself. That would go away there and there. And you'd get 5x equals 23 minus 3, that's 20. Divide both sides by what's in front of the variable. And then you have your answer on this one. X equals 4. If I plug that back in, up here 5 times 4 plus 3 does in fact equal 23. On number 6, it looks like I think the easiest way to do this one would be to subtract 2x from both sides and to subtract then 16. So I'm moving the x's to the right. I'm going to move the 16s to the left. Let me write that a little smaller so I can fit that in there. So I'm going to just write the same things, but minus 2x minus 2x, and then minus 16, minus 16. These will go away, and these will go away. I'm left with, this looks like negative 9 equals, that would be 3x. From there, divide both sides by 3. The 3's would cancel when you do that. And you've got your answer on this one. Negative 3 equals x. And you can plug that back in. They're getting a little more complicated or a little more difficult to check. Not really difficult, but just going to take a little bit longer to check. But I think that's when it really becomes more valuable, when you have multiple steps that you've done and then you go back to the original and check it. So this would be negative 6 plus 7, that's 1. This would be negative 15 plus 16, also 1. So you have 1 equals 1. The check works out. On the next one, we've got 2/3. We would distribute that through to both of those. We have a positive 5 right here. We would also distribute that there. And remember, you can think of things being over 1 with fractions, or you can change things into fractions like that if you wanted to. That's not really going to help me over here to think of those as fractions, but it may help me over here. So let's see what I have after that step. I've got 2 times 6x on the top. That would be 12x. Let me get my blue out there. There we go. 12x over 3 times 1 on the bottom, 3. 2 times 30 on the top would be 60. 3 times 1 on the bottom would be 3. Some of you, I bet, could skip this step and go right to that next step. That's totally fine if you can, but this is a kind of an intermediate step if you find that helpful. Distribute the 5, the positive 5. You've got positive 5x, and you've got positive 20, and you still have that minus 2x there at the end. So let's simplify what we have here. Reduce that fraction. That would be 4x. Reduce this fraction. 3 goes into 60 20 times. And then over on the right side, it looks like I could combine like terms. I've got an x, and then 5 more x's, and then minus 2x's. So that would be 6x minus 2x, which would be 4x. And then in class, we talked about something like this. Well, look at this. You have the same thing on the left and the right. I could subtract 4x and subtract 20 and go through those steps, but when we got to something like this, we hopefully remember to say, oh, something equals itself. That's always true. So my answer is going to be all real numbers. And if you wanted to use that fancy symbol for that, you can say or, write a capital R, but draw a second line, vertical line through the R, and that will stand for that. Let's see what we got for number 8. It looks like we're going to distribute a negative 3 in this one and distribute a 5 on that side. That will leave us with negative 3h, negative times negative, so it's positive. 3 times 6 is 18. And then this was 5 times 2h, that's 10h. And 5 times 3, that's 15. Some options here. We could add 3h to both sides, subtract 15 from both sides, or we could subtract 10h from both sides and subtract 18. I'll keep my variable parts positive as often as I can, so I'm going to add 3h. That means the h's move to the right, the integer numbers need to move to the left then. So subtract 15 from both sides. The regular numbers are gone over here, the h's are gone over here, and I'm left with, this would be 3 equals 13h. And then I can divide both sides by 13. 13's will cancel, and I'm left with my final answer. Let's leave it as a fraction. That would be my best answer. Don't approximate that as a decimal unless you're told that you can do that. So 3 over 13 equals h. That looks like the best answer for that one. Moving on then to number 9. Let's see what numbers 9 and 10 actually say. So now we're going to solve these formulas in terms of a variable. We did this with lesson 3.8. So solve for r. We're trying to get r by itself then in this equation. So it looks like, well, I don't like this fraction over here. I want to move the fraction over there or get rid of the fraction. Why don't I rewrite that whole equation a little bigger so that we can see it a little better. This is v equals 1/3 pi r squared h. That's actually the volume formula for a cone. So a cone looks something like this. You don't have to know that that's a volume formula for the cone. We need to know how to manipulate this though. So it looks like, well, to get rid of this 1/3, I can multiply by the reciprocal of 1/3. I can multiply both sides by 3. That's how I'm going to start this one. The 1/3 and the 3 will cancel each other out. You have 3v then equals pi r squared h. And we're trying again to get r by itself. We're solving for r. So if I divide both sides now by anything that's not r here, I've got pi times r squared times h. To undo those timeses of pi and h, I can timeses, I'm not sure if that's a word, but let's just go with it. The pi's will cancel and the h's will cancel. If I divided by pi and h over here, I got to do the same thing over here. Divide by pi and divide by h. That leaves me with 3v divided by pi h equals r squared. And then in class we talked about how when we have something like this, we want to take the square root of both sides to get rid of the square. That's going to leave r by itself, what we were trying to solve for in the first place. So it's 3v, 3 times the volume, divided by pi times the height is going to be plain old r. The square and the square root canceled right here. Number 10, solving for a now. I'm going to rewrite that equation. Ax, a times x in other words, minus 5 equals b. How can I get a by itself? I actually think this one's a little easier than this one. So if we add 5 to both sides, the 5's will cancel. Nice. And then we'll have ax, this is gone, equals b plus 5. To get a by itself, since it's a times x, let's divide by x. And then if I do that over here, I have to do the same thing over here. I'm dividing the whole thing there by x. By doing that, the x's will cancel, and I'm left with a equals b plus 5 over x. That is solved in terms of, or solved for a in terms of x and b. So a is by itself, we solved for a. That's our final answer for number 10. Moving on to number 11 now. 11, 12, 13, 14, and I also think then through 18. These are all solving each inequality and graph a solution. I'm actually going to take a moment, pause the video, and add some number lines in here. I meant to do that, but we're going to be having to graph each solution. And just like that, magic. All right, we've got number lines here now that we can use. So on this first one, with these inequalities, I have h divided by 3 is less than 9. I'm going to rewrite that so that 11 isn't in the way. How can I get rid of divided by 3? I can multiply both sides by 3. And then by doing that, the 3's will cancel. I'm left with h. And then I did not multiply or divide by a negative number, so the sign stays pointing in the same direction. H is less than 27. That would be my solution to the inequality. Remember, you might see it like this too. I'm not going to write this for everyone, but h such that h is less than 27 in that set notation or set builder notation. You might see it like that too. That would be acceptable, but for the purposes of what I'm looking for, this is totally fine as well. So 7 or 27, put that on the number line somewhere. We got 0. At least put 0 somewhere, and then put the positive numbers to the right of that, negative numbers to the left of that in appropriate places. We're talking about things that are less than 27. So open circle, it's not or equal to, and then if it's less than, we're going to shade this way, shade in that direction. Let's keep moving. Number 12, I'm going to rewrite this one. Negative 2/3 x is greater than 2/5. So just like before, we had something, a fraction times the variable. To get rid of that fraction, we can multiply by the reciprocal of that fraction. So I'm going to multiply both sides by -3/2. Now I multiplied or divided by a negative here, so this will cancel here and here. Those are reciprocals, and you'll still have x on the left side, but since I multiplied by a negative number, I have to flip the sign. That's a rule I just need to remember. I could cross cancel the 2 and the 2 here. Not cross multiplying, but the 2 and 2, they have a factor in common. Could make that a 1 and a 1, so if you wanted to do that right away, you could. But let's say I didn't see that. I'm just going to multiply straight across. That's -6/10, and that can be reduced then to -3/5. It looks like that would be my final answer. I could put 0 here, -3/5 to the left of that, and it's less than, so open circle and pointing to the left for that. If it was less than or equal to, then that circle would be closed. Number 13, we're dividing here by 2.8, and we have k as our variable. This will go away, and that would leave me with, I've done the work on this one already. This gets me, you could use a calculator for something like that. But this is 7/2, or if you do that as a decimal, 3.5. So 3.5 is less than, greater than, excuse me, I didn't multiply or divide by a negative, greater than or equal to k, but an equivalent way to write that, usually I say it's best to write the variable first, and it's eating the bigger number, 3.5 here in this case, so k is less than or equal to 3.5. That's an equivalent way, and in my opinion, a better way to write that. And so we would have something like this, 0 and 3.5. This time it is or equal to, so we have a closed circle at the point, and then pointing to the left still, since it is less than. Shade that, draw in an arrow, because it's going on forever in that direction. Number 14, this one, I'll rewrite that again so that number is not in the way. The number 14 is not in the way or confusing us. What can I do from there? Well, I'm trying to get f by itself. To get rid of this divided by 2, I can multiply everything by 2. So let's do that first. Goodbye, goodbye. See you, 2's. And you're left with 3 minus 4f is greater than 2. Keep working that through just as if it were an equation. And so the 3's would cancel there. Left with -4f is greater than -1. And it looks like in this case I'm going to be flipping that symbol again, because I'm going to divide. I'm going to have to, for my last step, divide by a negative number. So divide by -4, divide by -4. The -4's cancel, and that leaves me with, ran out of space there, so I'll write my final answer over here. We divided by a negative, so we flip the sign. Negative divided by a negative is positive. 1 divided by 4 would just be 1/4. Since this is in a fractional form, I'll leave my answer as a fractional answer. You could write, and technically be right, you could write f is less than 0.25 or 0.25. That would be acceptable as well. But I'm going to put 0, I'll put 1/4, open circle, and pointing left once again. So lots of them pointing left so far. We haven't had any greater thans in the end when we solved our inequalities. Let's do a few more of these. We've got 15 now. On this one, I'm going to write kind of small here, but -3t or -3t will get rid of the +3t here. I move the t's to the left. I need to move the integer values to the right then. So a -8 will get rid of the +8. And that gives me, it looks like 2t. And this is less than or equal to -11. I can divide both sides by 2. The 2's cancel. That leaves me with my final answer. T is less than or equal to negative 11 over 2. You could also say that T is less than or equal to negative 5 and 1/2. That's the same thing as 11 over 2. Or you could even say T is less than or equal to negative 5.5. So all of those would be acceptable answers to me, unless you're told specifically that you have to have it in a certain form. So I'm going to go with this one, but just even writing it down this time, this would also work, this would also work. So let's have 0, and then I'll say this is negative 11/2. We got a closed circle this time, but yet it is still less than. We've got 5 in a row that have been less than. So that's going to point to the left. Number 16, distribute that 3 and distribute the 2. In the next step then, that's 3 times negative w. That's negative 3w. It's 3 times negative 6. It's negative 18. We got less than 2 times 2w. That would actually be, let me write the right number in there, 4w. 2 times 8. That's going to be 16. And then plus 1 just kind of hanging out by itself out there. And so after we've done that, let's get the w's on one side and the integers on the other. First, let's combine like terms though on the right. I notice there's nothing to combine on the left, but I can combine 16 and 1 on the right side. That would be plus 17. So I'll do that first. And now I'll get the w's. I'm going to keep my variable parts positive, so I'll move them to the right. That means I would have to move my integers to the left. This is gone. This is gone. We're left with negative 35 is less than 7w. From there, divide both sides by the coefficient in front of that variable. That coefficient will be canceled by the divided by 7. We did not multiply or divide by a negative. So we have negative 5, though, is less than w. That would mean, and again, I think this is the better way to write it with a variable in front. That would mean that w would have to be greater than negative 5. So if we had 0 here, negative 5 here, hey, we got a greater than 1 finally. So this is open circle, it's not or equal to, and then pointing to the right in this case. Number 17. Looks like some more distribution to do here. We've got a 2.1. Distribute that through. That would leave us with, we got 1.9 plus 1.7x is less than 2.1 times 3 would be 6.2. And then 2.1 times x would be 2.1x. And it looks like to keep my variables positive, I could do this. It's okay if you make them negative. It would be okay to subtract 2.1x. I'm just choosing to do that instead this way. I'm going to subtract 1.7x. So the x's are now on the right. That means my normal numbers need to go to the left. I could actually multiply everything by 10 if I wanted to, and that would move the decimals, so I wouldn't have to deal with decimals. That's an option. If you did that, that'd be totally fine. But this would be 1.9 minus 6.2. That looks like that would be negative 4.3. These are gone, they canceled. And then right here you've got 0.4x. You can divide by that 0.4 in front of the x. That would cancel out here and here. And that would leave me with, as a decimal, negative 10.75. I divided by a positive number, so the sign stays the same, pointing in the same direction. So if that's true, that would mean that x is greater than negative 10.75. So if I had 0 here, this could be negative 10.75. I'm using decimals because that's how my answer, how my question started. I would be having an open circle, and alright, we got another greater than, so we got 2 in a row now. Greater than was feeling left out on those first 5. We had that one, and then those other 4 were all less than in the end. Greater than's feeling a little better now. Number 18, on this one, looks like we could multiply by 7 first of all to get rid of that divided by 7. If I do that on the right side, I got to do the same thing here on the left side. We're going to have to distribute that 7 through. These 7's will cancel. I'm left with 14 minus 21b is greater than, and all I have left there is 11 minus 15b. If I added 21b, that would keep my variables positive. I like to do that, so this is gone there. Subtract 11. That gets rid of my integers on the other side. This would be 3, and is greater than, this would be 6b. If I divide both sides by 6, there's no sign flippage with that. We are going to cancel out those 6's though. This could be reduced down to 1/2. So we would say 1/2 is greater than b, which would mean that b is less than 1/2. So best answer I think is that form right there. You've got 0, you've got 1/2 could be right there then. You'd have an open circle and pointing now back to the left. So less than made its triumphant comeback. Number 19 now. So these ones, directions say translate each phrase into an equation, expression, or inequality. So now I'm reading the sentence and making a mathematical equation, expression, or inequality out of it. So first of all, the product of 5 and a number y, that would be 5y. And then it says is, that means equals 2 less than the quotient of 4 and y. So it's 2 less than, that means it's minus 2, and then the quotient of 4 and y looks like this, 4 divided by y. That's the quotient. When you hear quotient, that's divided by. When you hear product, that's multiplied by. So 5y equals 4 divided by y, all that minus 2. It's 2 less than that quotient. Number 20, x times 7, that would be like this, 7x minus 5 times y, just looks like this, minus 5y, equals the quotient of x and 2. So x and 2's quotient, that would look like this, x divided by 2, that would be it. That would be my final answer for that one. 21, negative 3/7. Negative 3/7 looks like that, plus a number. If we don't know what that number is, we can use whatever variable we want. I'll go with x, and then it is, so it equals, but here it says at least 2, so I was a little preemptive there in what I wrote. So it is at least 2. Let's put that all together. So that means it could equal 2 or it could be higher than 2. So this is the sign we would use for that, greater than or equal to 2. And number 22, a number less than 15, or not, I'm sorry, I read that wrong. I inserted the word then in there. That's not there. So a number less 15, that's another way to say a number minus 15, but just a little less of a well-known way to say that, I would say. So a number less 15, a number minus 15, we'll say x minus 15, and that is greater than, so that's strictly greater than, not or equal to, the sum of twice the number and 8. So the sum of twice the number would be 2 times x, and 8, the sum of those, that would look like that, 2x plus 8. That would be it for that one. Notice it's not saying to solve these, it's just saying to translate each phrase into an equation. We could solve this one for y, we could solve this one and this one for x, and we could solve this one for x. It doesn't say to do that though, so please don't waste your time doing that. It doesn't say to do that. The directions for these ones says to answer the following questions and to show all your work. Sounds pretty straightforward to me. What ratio forms a proportion with 8 over 36? So when you're asked what ratio, that means what fraction, in other words. So you can think of what fraction forms a proportion. There's more than one, but if we were to reduce this, I think that would be the most obvious one. So 8 over 36, if we reduce that, divide both sides by 4, that's the biggest number that can go into both of those. We could say that would equal 2 over 9. That's the ratio. This is the answer. Just that fraction. But notice I have set up a valid proportion here. 8 over 36 does in fact equal 2 over 9. I have a one ratio equals another ratio. One fraction equals another fraction. The whole thing is a valid proportion, but the ratio or the fraction right here is the ratio that would form that proportion. Number 24, solve the proportion. So on this one, let's cross multiply. So we had 1/8 equals 7 over 2h. Cross multiplication leaves you with 2h times 1 on one side, that's 2h. 8 times 7 on the other side is 56. You can divide both sides by 2. The 2's will cancel, and you're left with h equals 28. Number 25, to find the percent of change, we're going to do the amount increased or decreased divided by the original amount. So first of all, is it amount increased or decreased? So I'm going from 45, looks like I'm going up 9 to get to 54. So it's amount increased over original amount in this case, and that's going to equal 9 over the original was 45. So 9 over 45, that is reduced to 1 over 5. Divide both by 9 and you get that. But it's a percent of change, so I need to write this as a percent. That's 0.2 as a decimal, or 0.20. To change a decimal to a percent, move that 2 spots and you'll get your percent value. Looks like that would be 20%, a 20% increase in this case. Number 26, find the discounted price. If you have a radio that is being sold for $45 and there's a discount of 30%, we need to find what's 30% of that number and subtract it from that number. So first of all, what's 45 times 0.30? That's what 30 is as a decimal. You could just say 0.3. That would be fine as well. So 45 times 0.30, I've calculated this out. Prior to this, it was 1350. So you could use a calculator to figure that out. 1350. It would be that much off. So that's an important piece of information. I'll circle that, but I won't box it in. I'll box in my final answer. 45, though, minus that, minus 1350, would give me my answer. And in this case, that would be $31.50. So that's the final discounted price. Notice that I included units on that. I included dollars since that was the units in the problem. I do expect to see that on a test, something like that. All right, we're still answering the following questions, showing all our work on these. These ones look like proportion type problems. So let's work on setting up some proportions. Mary is walking to the store. She is currently walking 3.2 miles per hour. So I could say that's 3.2, this is miles on the top, per hour, that's per 1 hour on the bottom. Some of these we're going to be able to solve really without setting up proportions, but I want to get some good practice doing that. This is miles and this is hours. So if we have that over here in that way, we have to do the same thing over here for the fraction that it's set equal to. So if we're going to set up a proportion, 3.2 over 1 would be a valid comparison as long as we compare it to miles and hours over here. The store is 1.6 miles away. So 1.6 to, well, how long is that going to take? That's what we don't know. Let's call that x. If you would have just said, you looked at that and said, well, couldn't I just take 1.6 and divide it by 3.2? You would be correct, actually. But getting good practice here, setting up the proportions. When it's just a 1 as one of the values, sometimes it's pretty easy then to not set up a proportion and just divide the numbers as you see fit or as you see them up there. But if we were to set up that proportion, we would have this. We could divide both sides by the coefficient there, and that's what I was talking about earlier. Could you have just done 1.6 divided by 3.2? Yes, that would have worked totally fine. This divided by this does give you 1/2, so it's 0.5 hours, or in other words, it's a half an hour, 30 minutes would be another valid way to say that. Number 28, the scale on a map is 1 inch to 5 miles. So you could say 1 to 5, that's inches to miles. So inches is here, miles is here. Guess what? You gotta compare the same things in the same way over here. So we gotta compare inches to miles then over here. So Darren wants to know how far the amusement park is from his house. On the map, his house is 3.25 inches from the park. How far is that? Should be his house. I'm gonna just let you know I didn't make these packets myself. I just kind of printed them out. So we'll make the little typo correction. That's okay. We all make mistakes. So how far is his house from the park? But that would be, we could call that X if we wanted to. And again, this one, since it's just a 1 to something ratio, it's pretty easy to do without actually setting up a proportion. But proportion setups are very helpful, I think, especially when that's not just a 1 to something ratio or a something to 1 ratio like it was over here. But if we were to cross multiply, we'd have 1 times x on one side. That would just be x. 5 times 3 would be 15, and then times 0.25 would be another 125, 1.25. So that's 16.25 altogether. 5 times 3.25, 16.25. And this is, I have units here. This was measured in miles. So the actual distance to the amusement park for Darren is 16.25 miles. On 29, Bob wants to buy 3/4 pound of peanuts, I would say. Peanuts cost $3.75 a pound. How much does Bob spend on peanuts? So if we're going to set up a proportion once again, I've got $3.75 per pound, or a pound. I could write that down as 3.75 over 1. This is dollars, and this is pounds. That's the abbreviation for pounds there, LBS. So I need to compare the same thing over here. I need to use the same comparison over here. So this is going to equal, now we're talking, well, what about 3/4 pound instead? So 3/4 could go on the bottom. How much does that cost? I don't know yet. So if I cross multiply though, I can figure that out. If you would have just done 3/4 times 3.75, yeah, that would have worked too. But make sure you know how to set up the proportions as well. So this would be 2.8125. You're not going to pay a portion of a cent. So let's round that off to the nearest cent. You would have $2.81 that you're paying for those peanuts. And then number 30, the ratio of boys to girls in the class is 3:2. If there is a total of 30 students in the class, how many, that should be a comma there, how many boys are in the class? So if there's a 3:2 ratio of boys to girls, that means the ratio of boys to total would be 3:5. So for every 5 kids in the classroom, 3 of those are boys. So we really need to use this instead of this as we set up our proportion. So I've got boys to total, because I know here what's the total amount of students in the class. That's 30. So I've got boys to total here and here. And I'm going to make the same comparison over here then. Boys on the top and then total on the bottom. I don't know how many boys in the class there are. I'll go with X. Keep it simple, and this would be 30 right there. So on this one, these other ones had something to 1 or 1 to something. That is not the case here. So definitely a lot more helpful, I think, to set up a proportion on this one. You'd have 5x equals 3 times 30 would be 90. You can divide both sides by 5. And the 5s will cancel. You've got your final answer there of x equals, and it looks like that would be 16. I'm sorry, that's not the right answer. It looks like that would be 18. So 18 times 5, yep, that is in fact what I'm looking for. Let me erase the 6 there. Change that to an 8. So 18 what? This was representing boys. We want to know how many boys are in the class. And if you think about that in the context of the original stated problem, that would mean there would be 12 girls. And so if we reduce 18 over 12, we should and do in fact get 3 over 2. So that definitely checks with the information that's up here. So notice on all those I included units. I expect to see something like that if you're one of my students taking a test. And on these ones we're using some triangles. Not exactly sure why this was hanging out there, so I'll just erase that. Let's imagine that these are all connected a little better. So this should be connected. For some reason when I brought up the page here to put stuff on, some of this stuff came up kind of funny. 3 should be with that, x is with that side right there, and the 4 is right there, the 2 is right there. So these are, we're assuming, similar triangles. So triangles ABE and ACD are similar. And if they're similar, that means they match up in the order that they're written. So ABE matches up in the same way as A to C to D does in the bigger triangle. So let's see what we've got. We've got 3 and 4. I could start with that. 3 divided by 4 would equal, so I've got this part. I'm going to use my highlighter for this. I've got this part to this part. That's going to match up with this part to the whole thing right here, the whole length going this way. It's not just this piece. That's a common mistake I see. It's the whole length. So this triangle, this matches up with this in the same way that this matches up with this. That means for the other proportion, the other fraction in the proportion, I could say, well, this is x, so it's orange to red, x to 2 plus 4. 2 plus 4 is 6, so I could say this is the same thing as that. Cross multiply that. You would get, I should say, 3 times 6 is going to be 18 on one side, 4 times x is going to be 4x on the other side. Can divide both sides by 4. The 4's will cancel. You can reduce 18 over 4, you can reduce that to 9 halves. So you could say x is 9 halves, no units included, so you don't have to include those. You could also say that's 4.5. You could also say that is 4.5. All those are the same number, just in a different form. And then here, so h is here, this side's 5, this side's 7. This is point h right there. And again, I'm not sure why it showed up on your copies, but it didn't show up here. This is point J, it looks like, down here. And this is I right here. K is right there. Here's X. So this one says triangles G, H, F, and I, J, K are similar. Just like before, that means they match up in that particular order. So G, H comes first. Why don't I make an orange mark on that segment? So the GH matches up with IJ, and HF, that'd be this one, matches up with j to k. So that matches up with this side. And I could also, I'll use a third color here. That means that side would have to match up with this side. And so from there, I can set up a valid proportion. I'll draw a little line there. This is number 32 stuff now. So we've got, well, I've got the green part and I've got the green part here. So I can write both of those down. 5 compared to 7, that's small green to bigger green, would have to be, looks like the orange, I don't have values there and there, but the red I do. I could say small green to big green, small red to big red. So that'd be 7 over x. There's my proportion. Now I just need to solve that proportion. So cross multiply, and you've got 5 times x, 5x equals 7 times 7, 49. Divide both sides by a 5, and in doing so, we not only finish this problem, but we finish the packet. We've got x equals 49 over 5. That would be valid. You could also say 5 goes into 49 9 whole times with 4 left over, so that would be valid. And you could also say that's the same thing as 9.8. And so that does it. If you watched the whole thing, that's great. I hope you found it really helpful. Make sure you got this stuff down. You're going to see very similar things on your test if you're one of my students. If you're not one of my students, I still hope you found this helpful in your preparation for whatever you're working on. Or go back, pause, rewind, fast forward, revisit problems as needed, as much as you need until you feel like you really got it down. Feel free to ask me if you're one of my students questions before or after school as times are posted. Beyond that, I hope you found this helpful. I hope you have a great day, and I'll see you later in class if you're one of my students.